Okay, so for some more examples on related rates, this is on the back. First one says a police car approaching the right angled intersection from the north is chasing a speeding car that has turned the corner and is now moving straight east. When the police car is 0.6 miles north of the intersection and the car is 0.8 miles east of the intersection, the police determine with a radar gun that the distance between them and the car is increasing at 20 miles per hour. If the police car is moving at 60 miles per hour at the instant of measurement, what is the speed of the car? So this one should look familiar. We did a very similar one when we did related rates. So let's label this. So you can use ABC, XYZ, whatever you prefer. I think I'm going to use XYZ. And I'm going to label this. Now keep in mind, if you labeled yours opposite, everything's going to be switched. I'm going to make that X, this Y, and that Z. So normally if you have only one triangle, the only formula you can really use is Pythagorean theorem. But let's go ahead and see what we can label first before we write that out. So when the police car is 0.6 miles north of the intersection, I would be careful of writing this on your picture because that is not a constant. X is not always 0.6. He's moving. So I'm going to write it down here. I'm going to say when X equals 0.6. The only thing I want to label on my picture is variables and any number that stays the same over time. So when X equals 0.6 and the car is 0.8 miles to the east, which would be our Y, Y equals 0.8. The police determine with a radar gun that the distance between them and the car is increasing at 20 miles per hour. So that's a rate, so we know that's a D number. What is that, the rate of X, Y, or Z? Well, it's determine that the distance between the police and the car. So that is this hypotenuse, this Z. So it says, so we could go ahead and label dz dt equals 20. If the police car is moving at 60 miles per hour, so the police car distance is X, and he's driving down. So if you notice, so that is our dx dt. And don't forget, if a variable is decreasing over time, then its rate should be negative. So even though it doesn't say negative 60, when we plug it in, we need to plug in a negative 60 because X is getting smaller over time. So when all this is true, it says what is the speed of the car? So the speed of the car is the rate of Y, so you're looking for dy dt. So at this point you can kind of figure out what you have, what you don't have. So I think sometimes it's helpful if we do write the equation first, and it's easier to see what you still need to figure out. So we would use the Pythagorean theorem. X squared plus y squared equals z squared. So if I don't need to replace anything, so I can go ahead and take the derivative. 2x dx dt plus 2y dy dt equals 2z dz dt. So if I go start to plug in, let's see if I get stuck, because the only missing variable I want to have is dy dt. Everything else I need to plug something in for. So I have 2, when x is 0.6, my dx dt is negative 60, plus 2 when y is 0.8, times dy dt, which is what we're looking for, so we just leave that one, equals 2 times z. Notice we have no z labeled. We have dz dt, but we need just z. So can we solve, if you ever get stuck, think about, can we solve for it based on what we have? Well, if you have 2 legs, you can get the hypotenuse at that given time, right? So I'm going to go ahead and draw my own little triangle, and it's when x is 0.6 and y is 0.8, how can we solve for the hypotenuse? We'll use our Pythagorean theorem, right? we know it's going to be 0.6 squared plus 0.8 squared equals z squared. So 0.6 squared plus 0.8 squared would be what? I should have known that. That's 1 equals z squared. So then technically you square root each side, but if you square root it, it's still 1. So we know at this point in time, we want to use 1 for z. Times dz dt, which we said is 20. Okay, now you just do your algebra and get dy dt. So 2 times 0.6 times negative 60. I did not type that in right. Is negative 72. Plus, we'll say 2 times 0.8 is 0.16. 1.6, sorry. I cannot do math today. And then 2 times 1 times 20 would be 40. And this one will add the 72. I'm sorry, I got distracted. And then we'll have 1.6 times dy dt equals 112. So then we divide by our 1.6. And that makes dy dt 112 divided by 1.6, which should be 70. So what, it probably bothers y'all when it's crooked the whole time, huh? Sorry. What would your units be? Well, y is miles, t is hours. It should match these other ones, miles per hour. You can write it like a fraction or put it in ph. Okay, this last one, I don't know why, but these are my least favorite. I feel like I get the most, jumbles on them. But that's why we got to do them. So this one says, a man is 6 feet tall walking away from a spotlight at L, located on the ground. His shadow is cast on a wall 40 feet from the spotlight. If the man is walking at a rate of 4 feet per second away from the spotlight, determine the rate of change of the shadow when he is halfway to the wall. Okay, so let's go through and label this. It says, well, they already have this man is 6 feet tall. He's not changing height, so that's a constant. You can put it in your picture. Now, it says his shadow is cast on a wall 40 feet from the spotlight. So this distance is 40 feet, and that's not changing over time. So if the man is walking at a rate of 4 feet per second, so what would that be? So maybe we should get some letters in here before we start talking. So we are going to, anytime it looks like this, we have a triangle within a triangle, you're going to use similar triangles, and it's going to be a proportion problem. I tried to do this problem earlier with x's and y's and make one capital, but then I quickly realized a lowercase x and uppercase x look similar. So we're going to use a and b. So I'm going to make the height of my triangle a and the base of the triangle b, lowercase for the little one. And for this big triangle, I'm going to make it uppercase a, and this corresponding side would be uppercase b. So you notice uppercase b is not changing and lowercase a should not be changing. But these two are changing over time. He's walking towards it, so db dt is increasing, and then our capital A should be, as he gets closer, the shadow is going to be getting smaller. Okay, so now we can maybe label some stuff. So it says, if a man is walking at a rate of 4 feet per second away from the spotlight. So that is this rate that B is changing. As he's walking, B is increasing at a rate, so D lowercase b dt, sorry, I didn't notice my elbow was, would be 4 feet per second. And it says, determine the rate of change of the shadow when he is halfway to the wall. So we want the rate of change of the shadow. The shadow is on PQ, so it's capital A. So we're looking for dA dt when Now let's think about this. He is halfway to the wall. So when he's right here, and he's halfway, what does that mean out of these letters? We know capital B is always 40, but what does that mean for lowercase b? If he's halfway, it should be 20. Okay, so let's go ahead and set up what we need to set up and see if we have everything we need. So you're gonna, when you're using similar triangles, use proportion. So you got to make sure you do corresponding sides. So I'm going to do lowercase a over lowercase b equals capital A over capital B. Now I will say in this problem, you need to plug in the numbers that are constant. That's what it was saying right here, is if a value is not changing over time, you can plug it in before differentiating. And it's going to make this problem a lot easier. So what's not changing over time? Lowercase a is always 6. Lowercase b is changing, and uppercase a is changing, and uppercase b is always 40. So now to make this an actual equation that we know how to take the derivative of, we're going to cross multiply. So 6 times 40 is 240 equals uppercase a times lowercase b. And I would leave it like that. I haven't tried it another way of solving it for one letter. I would just use this as your equation, and now we're ready to take the derivative of our equation, step 4. So when you take remember, don't forget, you got to do the derivative of the whole thing, both sides, with respect to time. So the derivative of 240, the derivative of a constant, is 0. If you keep that 240, you're going to get it wrong. And then when you do the derivative of this side, you have to use product rule. So the original second is b, lowercase b times dA dt plus, now switch it, a times dB dt. Okay, so now we're ready to plug in, and we'll see if we're missing. The only thing we should be missing is dA dt. So we have 0 equals b, lowercase b, which we're going to use 20. I was trying to stay the same in my colors. Use red when we plug in. Times dA dt, which is what we're looking for, so we can keep that. Plus uppercase A. Do we have that over here? We have not labeled that at this point in time. We know dB dt, we just need to get our uppercase A. So let's go back over here. And we got to use, always if you're looking for another variable, you're going to use that original equation that you set up. So we're going to use this proportion and say when lowercase a is 6, because it's always 6, and lowercase b is 20, you're talking about at this point in time, and uppercase a is what we're looking for, and uppercase b is always 40. Now solve that for uppercase a. So that would be 240 equals 20 times a, so divide by your 20, and that makes a, what is 240 divided by 20? 12. So uppercase A, we're going to plug in 12 for. Times dB dt, which is 4. Okay, so you should be able to solve that. Plus 48. So then we have negative 48 equals 20 dA dt. So then divide by your 20, which I don't have room. So I'm just going to write the answer. dA dt after you do negative 48 divided by 20, which theoretically you could leave your answer like that, or simplify it, divide each by 4, and you could write it as negative 12 over 5. And what would your units be? Feet per second. Oops. Okay, so I know that can get kind of like easy to follow along, but a little harder to do on your own. So There are a couple questions on your AP assignment for this week where you're using related rates, so make sure you practice those before our Zoom conference on Thursday so you can ask as many questions as you need during that. If you have any other questions, let me know. That is all I have for today's lesson.